Okay, so the next one is to construct a perpendicular bisector. Again, I'll jump over to Geometry Sketchpad. Let's just do a new one. So I'm going to take care of hopefully a couple here. So we're going to construct a perpendicular bisector of AB. Okay. So there's segment AB. To find its perpendicular bisector, the way we use the compass tool is we simply have to pick a radius. I'm going to show you this way. So I'm going to choose that for my radius here. Okay. I'm just going to put my pen in a random spot here. I'm going to make the radius too small to start with. I want to show you this. So if I decide to draw a circle centered at A with this small of a radius, what's going to happen is we end up not crossing. Okay. So one of the first things that my students do wrong is they might not pick a big enough circle, and then the circles don't cross. We don't get anywhere with that. Okay. So let's get rid of that. Okay, and then the other thing, we'll talk about this as well. All right. So let's say we choose a larger radius to work with. That's going to be the radius that I choose. So it's out quite a bit further. I just pick one of the holes to put my pen in, put the center of the compass tool on A, and of course you construct your circle. Okay, pick a large enough one so that we end up, when the circles do cross, we'll definitely get um, some points to work with here. Okay, bigger, a little bit bigger would have been better probably. So, but what I'm doing right now is I'm constructing this using the same exact radius. So these two circles have the same exact radius. One is centered at A, one is centered at B. Your compass tool will do this beautifully. The points where these two intersect are points that are the same distance from A, right, as it is from B. This is a point right here that's the same distance from B as it is from A, because we use circles with the same radius. Okay? Now the definition of perpendicular bisector is all the points that are the same distance from both of these two endpoints. Okay? All you need to establish a line is 2 points. We found 2 points right there and there. So those 2 points are points that are the same distance from A and B. If I draw a line through those, that's all the points that are the same distance from A and B. So this ends up being your perpendicular bisector. Okay? So a lot of vocabulary there. Remember, points that are the same distance from both endpoints. Okay? You want your circles to overlap a decent amount. A little bit bigger probably would have been better. That's probably your best bet right there. If you get something that looks like that, it's really safe to say that this line's going to cut AB in half and be perpendicular to it. Now I want to show you a mistake. And I'm going to check for this on the test. Okay? I have to check for this. Let's say somebody uses 2 different sized radiuses. You know, they'll use this one, this radius. They'll pick one hole for A. Okay? We call that the radius. So centered at A, use this radius, right? What if somebody uses a different radius, smaller radius, but centers it around B? Okay, what's going to happen? Well, what I want to teach you here is you will still get a line that is perpendicular to AB. But you can see right here that it's not in the exact center of line AB. Yes, you'll maintain perpendicular, but you'll lose the bisector portion. How do we gain back that bisector? Use the exact same radius for both circles. Now I'm going to have to check that. If you're one hole off even, it's going to be very obvious when I go and measure it with my compass tool. So make sure you double, triple check that you've used the same radius on both circles. Okay, so I might say if that happens, okay, you got the perpendicular, but you missed the bisector portion. Okay, so that is perpendicular bisector. All right, let's see if we can cover another one. So the next one is bisect an angle. Okay, so these are going right in a good order because we're going to use basically the same concept again with an angle. But watch what happens. Watch the modification here on this one. Okay, so I'll start with an angle. Okay, oops, get rid of that last one. All right, so angle right here. Oh, let's make it look like theirs. Let's see. Okay, obtuse angle here. That's fine. We can do that. So that's the center, or the vertex, I should say. Okay. And make it very obvious. Let's say that this one is, did they do that? Yeah, they made that a little longer. Okay. So I'll make sure this is a little longer. All right. So clearly those points, let me just label them here quick. Yeah, sure. That's fine. So clearly C and A are different distances from B, right? So we really shouldn't be using those points. Here's what I'll do. I'll use my own radius. Okay, I'll pick my own radius. This is what you're going to do for yours. You're going to put the center of your compass tool on B, pick any spot you want on the compass. A little bit bigger probably is better. Okay, so go out a little ways on the orange part, and you're going to construct that circle. Okay, here we go again. Just like we did in the other one, we start with that circle to get a set distance away from the vertex. Here we go. This segment is now created. A lot of people don't add the segment in when they teach it. I do because I really feel strongly that we have to use the same concept for multiple problems. Now this segment is the size of the angle. Okay, again, let's make sure we understand that. The size of the angle this far from the vertex. Of course, if you go further from the vertex, it's going to be a further distance, right? So this segment right here is what we would say is the size of the angle that far out from the vertex. Now, we're going to cut that in half. So you know how we just did a perpendicular bisector for a segment? We're going to do it again. And it makes a lot of sense to do this. Okay? So, I'm going to use a different radius. You can use any radius you want. Now, a little bit tricky here. It's going to get a little crazy, but this segment, okay, I'm gonna bisect this one right here. Okay, this is the radius I'm going to use. So I'm going to put my center of my compass tool on this point. If I use the same radius over on this point, you're going to see this again. If I got rid of everything else for a minute, just for a minute, hide those. I didn't hide enough. Look at that. Does that look like the one we just did? Right? It bisected, perpendicular bisector of a segment. So let's put those things back. Undo. Hopefully let me undo one more. Perfect. So that's exactly what I'm doing. First, get a segment that represents the size of the angle, right? And then we're going to construct the perpendicular bisector of that. Here we go. That's going to be the angle bisector. Okay. Now, all the stuff, so this is optional. A lot of people don't draw that in, but that's essentially what you're doing. Okay. So that's going to be perpendicular bisector, or sorry, angle bisector. All right, next one. Perpendicular through a point on the line. All right, we're almost to the 10 minutes, so I'll stop there.